So, Darryl, why is it I have to pay for this three-element rosette that Micromeasurements build? Why can't I build one out of three uniaxial gauges and do the very same thing? Seems like it'd be a lot easier.
Well, Tom, that's a great question. We go to a lot of time and effort in designing a three-element rosette to make sure that the grids of the rosette are at fixed angles to each other. You know, the rectangular style rosette is at 45-degree directions, where the delta is at 60-degree. And if you think about it for a minute, when we start producing the gauge, we start out with an image that's anywhere from about 50 to 100 times the actual size of the gauge that you get in the package. And then we photographically shoot it down. And as we photographically shoot that down to a master, that reduces those errors of one grid relative to the other. That being said, basically they're very precise, where if you try to create your own three-element rosette, you're going to have some uncertainty, and that uncertainty is going to be associated with how well you align those gauges, one relative to the next. So using a three-element rosette made by us, you're going to ensure that you reduce that uncertainty to a smaller percentage as possible.
So, what's the difference between a planar and a stacked rosette? Why would I care?
Another great question. A planar rosette is one that has three grids that are all side by side or in the same plane. Planar rosettes are very commonly used in structural testing. One of the advantages of using a planar rosette is that each grid has the surface area to dissipate its heat into the structure or the material that you're testing. Where conversely, if you take a stacked rosette, now you've got multiple grids stacked on top of each other, and each one is trying to heat up the other. So if you use a stacked rosette, you really have to watch your excitation levels, because if you use a normal excitation level like you would with a uniaxial gauge, you may find that you run into some self-heating problems with a stacked rosette.
So, what about in a stress concentration? I mean, don't I want to have the three grids in the same strain field? And isn't that why a stacked rosette might be preferred in a stress concentration?
Yeah, that's a great point, Tom. The reason for using a three-element stacked rosette is when you have those stress concentrations, and what you're trying to do is reduce the amount of error that you have, because on a planar, by definition, they're side by side rather than measuring at the same spot, where a three-element stacked has those three grids really at the same spot on the part. So it really helps to reduce the error associated with a strain gradient that might be different from, say, grid 1 to grid 3. And a three-element stack really helps to focus the area of measurement down to about as small of an area as we can. And either one, you can use the equations to take the three separate strains and calculate your maximum and minimum principal stresses, as well as the direction of those principal stresses.
So what you're telling me is, if I'm smart, I'll buy the right rosette from Micromeasurements so it's aligned properly and I can use it and get the right numbers.
Absolutely. If accuracy or integrity of your data is important, you really need to be using a three-element rosette when the situation or application calls for it.
Thanks, Darryl.
Sure.